Hey everyone, my name is Dhruti Pathak, and this is my presentation for AP Chemistry Topic 2.4, the structure of metals and alloys. To begin, what is a metal? A metal is a substance made of a single type of element, typically found on the left and center of the periodic table. Metals have a crystalline lattice of closely packed atoms, where valence electrons are delocalized in a so-called sea of electrons. This structure gives metals high electrical and thermal conductivity, malleability, which is the ability to be hammered into sheets, and ductility, which is the ability to be permanently deformed without breaking. Now that you know what a metal is, what are some common metals in the day-to-day world? On this slide, we can see pictures and symbols of three really common metals in today's society. They are iron on the left, copper in the middle, and aluminum on the right. But what do all of these metals have in common? As stated on the definition slide of a metal, all metals have attraction between positively charged metal ions and delocalized valence electrons that move freely through the structure. This is often referred to as a sea of electrons. Now that we've established what a metal is, let's talk about alloys. An alloy is a homogeneous mixture of two or more elements where at least one is a metal. Alloys retain basic metallic properties, but are also designed to enhance mechanical strength, corrosion resistance, or hardness. They form by either substituting atoms of similar size, substitutional alloys, or filling gaps in the metal lattice with smaller atoms, interstitial alloys. Just like with metals, there are a lot of alloys which you encounter in the day-to-day world. Three common alloys are brass, steel, and sterling silver. Brass is comprised of copper and zinc, steel is comprised of iron and carbon, and sterling silver is typically comprised of silver and copper. As I touched on the definition slide of an alloy, there are two primary types of alloys. They're the substitutional alloy and the interstitial alloy. On this slide, you can see a visual of both types of alloys and how they differ based on structure. As you may have noticed, there is a major difference between the structure of an interstitial and a substitutional alloy. An interstitial alloy forms when smaller atoms fit into the gaps, interstices, of a larger metal lattice, making the alloy harder but less malleable as there is less space between the atoms. An example of this would be steel. On the other hand, a substitutional alloy forms when atoms of a similar size replace each other in the metal lattice, keeping a similar malleability to the pure metal. Examples of this include brass and bronze. Now, using what we've learned, let's do a quick practice question. Steel is often harder and stronger than pure iron. Based on your knowledge, explain why steel's properties are different from those of pure iron. The answer is that steel is an interstitial alloy where carbon atoms fit between iron atoms, restricting their movement. This makes steel harder and stronger than pure iron, which is more malleable due to its freely moving atoms. If you didn't get that question, there's no need to worry. Here are two additional resource links that will take you to extremely helpful YouTube videos that you can use to further your understanding of this concept. Thank you for watching!